All right, the next lesson we want to work with deals with fractional equations. Fractional equations, and we're going to look at the system of three linear equations, which is a system of equations we've already worked with, but we've got one or two of them, in which we've done elimination substitution in order to find an intersection point. Now what happens when we have three lines, where those three lines intersect that? Sometimes when you start talking about a system of three linear equations, you might get into three-dimensional, which means you have an x, y, and z axis. So you would have your normal x, y axis that you think of, but then z would be the plane that's coming out towards you. So you're looking at three-dimensional when you deal with that. So that gets just a little more complicated, but still working through the same processes as far as elimination substitution is concerned, just dealing with more variables. So the first thing we want to look at deals with fractional equations. How many of you like working with rational expressions? Remember, a rational number means you have a fraction. Do you like working with fractions? Guessing no. So one way we can work through this is to get rid of the fractions, and it's going to be a good technique to use when you get to future problems where you are used to doing something like this, but you use elimination substitution. And it's like, how can I eliminate the x's when I have 3 7s and I have 3 hundredths? How do I get those to be opposites so that they eliminate from each other? How do I get 2 fifths and 2 tenths to be opposites so I can eliminate them from each other? So an easier thing to do is to be able to get rid of the fractions or get rid of the decimals and change them into integers so you can work through the problem a little bit easier. So when you're encountering a rational expression, or this is actually an equation, when you encounter a rational equation and you are asked to solve, you can get rid of, you can only do this if it's an equation where you have an equal sign. You can get rid of the fractions by multiplying every single term by the common denominator across both sides of the equal sign. So we want to look at each one of the denominators, which is 7, the quantity x plus 2, and 3, and determine what is that common denominator. What's a common denominator?
21 times x plus 2.
The common denominator is going to be 21 times the quantity x plus 2. I want to multiply, algebra, it's okay to multiply both sides of the equation by the same value. It doesn't change the solution. So I'm going to multiply both sides of my equation times 21 times the quantity x plus 2. So if I do it to the left-hand side of the equation, I have to multiply the right-hand side of the equation by the same value. Now on the left-hand side, what do? The distributive property. So basically what you end up doing is taking every single term times that common denominator. When you do that, I need to simplify. To simplify, we know that numerator denominator of a fraction can reduce. So 7 goes into 21 3 times. So I'm going to take the 3 times the 4, which is 12, and I need to multiply that times the quantity x plus 2. If I look at the second fraction, the quantity x plus 2 cancels, and I am left with 21 times 3. Once again, I got rid of a fraction. So far, I'm changing it into an expression where I just have integers. And if I look at the last part, or the right-hand side of the equal sign, 3 goes into 21 7 times, and you end up with 35 times the quantity x plus 2. Now, does this right here look like an equation you can solve? Yeah, looks a lot better than the fractional expression that I had up above. So to solve, it's pretty simple, multiply. So I'm going to use the distributive property, 12x plus 24 plus 63 equals 35x plus 70. Group your like terms together. 12x plus 87 equals 35x plus 70. I'm going to try to keep positive numbers. So subtract 70 minus 12x and you get 17 is equal to 23. So if you solve, you divide by 23. So if I divide by 23, x is equal to 17/23. A lot easier than trying to go ahead and solve through it working with fractions. You could, this process is going to be an important process later in solving other types of problems. You could get a common denominator on the left-hand side. When you get that common denominator, you're going to have a fraction equal to a fraction, then its cross products are equal, and you could solve from there. That's okay. But I like to just multiply everything by that common denominator and simplify. And if it gets to be big numbers, you can just say 7 times 3 times x plus 2. And the 7s will drop out, and you can see what you were left with, what that other factor should be. Question? So what happens when, this is why that method becomes really important, because this is a system of equations. They are both going to give you the graph of a line because it's y to the first power, x to the first power. So they're both graphs of lines. We could change it into the y equals mx plus b format so you could see what those graphs actually looked like, and you can find an intersection point. But if not, when you solve this system of elimination or solve this system of equations, you are looking for the intersection point between those two lines. And two lines intersect at one point, unless those lines are parallel. If those lines are parallel, then you don't get a solution because parallel lines do not intersect each other. So you could type it in on a graphing calculator. I see one person has their graphing calculator out. But you have to rearrange, 2 people do, you have to rearrange that equation in order to get it into a form that you can type it into your graphing calculator. So if we just want to do elimination substitution in order to solve, we go back to what we just said about how do I get rid of fractions within an equation. Multiply by the common denominator. What's the common denominator?
35.
35. So I'm going to multiply both sides by 35, but if I use the distributive property, I'm going to multiply both terms on the left-hand side by 35. When you do that, 7 goes into 35 5 times, and 5 times 3 is 15x. 5 goes into 35 7 times, so 7 times 2y is 14y. And then I get 35 times 11. Do you remember how to multiply that? 385. You split the two numbers and put their sum in between. So remember that? Multiply by 11. Nope. The bottom, how do I get in the second equation? How do you get rid of the decimals? You would multiply both sides by 100, but that just means that we're going to move our decimal point over 2 places in each term. So the equation becomes 3x minus 20y equals negative 37. Now that looks familiar, right? What do you do from there? Elimination or substitution. Which one do you prefer? Okay, so we'll multiply the bottom equation times negative 5. So the top equation is still going to remain as 15x plus 14y equals 385. Okay, so I'll be multiplying. The bottom equation becomes negative 15x plus 100y equals what? 185. Elimination substitution. As you do that, the x's, 15x and negative 15x drop out. You get 114y is equal to 570. And I believe if you take 114 times 5, you get 570. So when I come back over here and I divide by 114, y is equal to 5. Y is equal to 5. Are you done? No. We got to figure out what x is. Where do I go back and figure out what x has a value of? You want to put it in with the fractions? No. Put it in the red one. That's a good one to this one right here, right?
Yeah.
So we're going to take this equation here because it seems easier. We don't want the decimals. We don't want the fractions. And we found out which value is 5? Y is 5. So we're going to have 3x minus 20 times y, which is 5, is equal to negative 37. So 3x minus 100 equals negative 37. So you're going to add 100. 3x is equal to 63. So x is equal to 21. So what is the intersection point between those two lines? It actually intersects at the coordinate point 21, 5. There's the intersection point of your two lines. So the first example that we looked at, getting rid of the fractions, is nice, and you can see where it can help you when it comes to solving a system of equations, finding an intersection point. Everybody okay with that?